Hi guys, today we're going to look at area of polygons. We work with three main polygons, the rectangle, the square which is not drawn here, and the triangle. So you've been working with the area of rectangles for quite a while, and we know that the area is equal to length multiplied by breadth. As long as your units are the same measure, so we've got centimeters and centimeters, all we have to do to calculate that is to use your calculator, multiply your two values together, and remember to put units squared. So I start off my notes not in your textbook. I just wanted to explain some things to you first. So working from the area of a rectangle, three quick examples here. This area is equal to 6 times 8, which gives us 48 centimeters squared. For question B, we just multiply 18 by 26 to get 468 centimeters squared, and the last one we'd multiply 11 by 7.5 to give us 82.5 centimeters squared. So those are straightforward rectangles, and it would be the same as if we put little grids over these and counted the number of squares within the shape. So now the area of a triangle, if you watched my YouTube video of cutting out shapes to make triangles to find the area of them related to a rectangle, you would have noticed that if we had our rectangle and we cut a triangle from it, when we flip this shape over, it fits perfectly onto this shape, and when we flip this shape over, it fits perfectly onto this shape, which means that a triangle is exactly half the area of the rectangle that it fits into. So it must have the length of one of the sides of the rectangle, and it must have the same perpendicular height as the rectangle. So we say that the area of a triangle is equal to a half of the base times by the height, or otherwise we can say it's the base times the height divided by 2. So a half of and divide by 2 gives us the same value. So to practice this, we're going to just try some few simple triangles before we get on to the tricky ones. So the base of this triangle is 8 centimeters. Its perpendicular height, as given there with the perpendicular, is 5 centimeters. When we multiply them together, we get 40, and dividing by 2, we get 20 centimeters squared. Again, here we have a base of 6 multiplied by the perpendicular height of 5. We get 30 divided by 2 gives us 15 centimeters squared. The last one, we have a base of 10, a perpendicular height of 6, multiplied together gives us 60, divided by 2 gives us 30 centimeters squared. So the very first question I asked you to do in exercise 9.2 throws the question backwards at you, the same way we looked at the questions yesterday, where they give you the area this time, and now they ask you to find one of the dimensions. So here they're asking you for the height of this triangle. They give you that the base of it is 5.2 centimeters. So the only way to work out the missing side, which is its height over here, is to fill all the information you do know into the area formula. So we say that area is equal to base times by height divided by 2. So we're given the area as 26,58. It's equal to the base, which is 5,2, times by the height, which we don't know, and divided by 2. So now we have to kind of unpick things to get this h on its own. We want to know what the value of h is. So the easiest thing to unpick first, instead of divide by 2, let's times by 2, because that will undo the divide by 2. So if you do this to this side, then you must do it to this side, because it's a bit like a seesaw. You've got to keep it balanced. So we times this side by 2, and we times that side by 2. And on your calculator, it will give you 53,16. So we've got rid of the divide by 2, but we still have 5,2 times by h. So we only want what h is. We only want to know what the height is. So to undo a times by 5,2, we should then divide by 5,2. Remember that times and divide undo each other. They're inverse operations. So if we divide by 5.2 over here and divide by 5,2 on your calculator over here, then we're going to get h all on its own over this side equals, and your calculator value should give you 10,22 centimeters. The next one is a nice easy one. This is the kind we hope for, where we've got a straightforward base on your triangle, and this, even though it's not inside your triangle, the perpendicular height is the highest point on your triangle. If you dropped a piece of string from that highest point, the length that it would hang down on until it reached the floor. So in this example here, if I use the side of it, that is not a perpendicular height, so I can't use that side. I must run a perpendicular, and we use the base, which is 24 millimeters, multiplied by 11 millimeters and divided by 2. On your calculator, that gives you 132 millimeters squared. So I've jumped a few questions here. I'm on to question 4. And the only thing I want you to pay attention to in 4a is to make sure that when you do the calculations for this one, remember the area of a triangle is the base multiplied by your perpendicular height. So this 8 over here is just to trick you. They didn't put that in there for you to calculate with, because we need the two lines that meet at a perpendicular multiplied together and then divided by 2. So this should be 10 multiplied by 6 divided by 2. So the answer for this one should be, I don't know, you calculate it. This one over here, so the picture you've got doesn't have all these pretty colors on it. I want you to divide this picture up into the shapes you know. So we know this shape over here, it works out at being a square, because here we have 4 and here we have 4, and this will also be 4 because of these perpendicular lines. And then if you take 4, the length of this, away from 7, you're going to get what's left over here as 3. So this 5 again here is just here to trick you, because we don't use this 5 to calculate area. You only use perpendicular lines to calculate area. So for the first area, I've made this area pink and I've called it area 1. I've said is equal to L times B. Because it's a square, you could have also said L squared or side squared. It works out to be the same. So we're going to say 4 times 4 gives us 16. And this funny little thing here actually is a U, like U for umbrella, units squared. Because we're not given units on this, so we just say units squared. You can't say 16 squared without writing that little U there. The next part is this little blue triangle over here. So the base of this blue triangle is 3. The perpendicular height is 4. So we would say that the area is base times height divided by 2. 3 times 4 divided by 2 giving us 6. Add the two areas together and your total area is 22 units squared. Okay, so what you're going to find is area is one of your problem-solving sections in your tests, and so you will find challenging problems in perimeter and area. And this one over here is a good problem-solving question. I'm going to lead you into it. I'm not going to do the calculations for it. You can see the calculations and mark your work against the memo when I publish it. But for now, we need to look at the area of this shaded shape over here. And we can't break this shaded shape into any shapes with right angles, because there are no right angles given in this shape over here. And we don't know any of the lengths of these lines over here. So the only way to do this problem is to say, if you took the total area, so say for example this was an A4 piece of paper turned on its side, and we want to make this little pink shape here, you would simply cut off this triangle, you would cut off that triangle, you would cut off that triangle, and you would cut off that triangle, which would leave you with this pink shape here. So that's what we want to do with our calculations. If you first find out the area of the whole piece of paper, which is the orange shape over here, and then from that you subtract the area of the pink triangle, and then you subtract the area of the green triangle and the area of the purple triangle and the blue one, you will end up with this shaded shape in the middle. Note that I gave you a hint here. To find the area of the rectangle, you need to add the lengths on the bottom, which give us 12, and add the lengths on the side, which give us 11. So the area of the outside shape is length times breadth, which gives us 11 times 12. The rest is up to you to solve. Question 6 is also challenging. Do the best that you can, and if you are very stuck on this section, just try your best, and we will recap it when we get back to school.